Hey everyone, and welcome back. This is Writeups, a CTF hosted by Intigriti, and in this video I'm going to be covering the Pwn challenges. Specifically, I'm going to be covering one of the Pwn challenges that I wrote, Maltigriti. You can see I didn't submit the flag just because it's my challenge, so I'm going to be talking about the intended solution, and then I'll be talking about how I solved the other 4 challenges. I didn't talk to the challenge authors about these challenges, so I'm doing them all blind, and I'll just be talking about how I solved them. I think one of them might be slightly unintentional, but all fun challenges. It was a good CTF. A couple of housekeeping notes. We're now in Florida, in Boynton Beach. We'll be here for the month. And then next month, we're in Japan. I didn't post last month any videos. We had some family stuff, and we were very busy, and I just wasn't in the mood to post CTF videos. But now we're back, and we're recharged and ready to pwn. So yeah, let's get started. The first Pwn challenge is hidden. It says, not everything you see is what it appears to be. Can you find the hidden secrets and beat it? The author is OX Mohamud, and we're given a netcat port and a download file. For this challenge, it was a ret to win challenge, but there were a bunch of memory protections enabled. So first we had to find a leak, and then we could do the jump to win, or ret to win. Taking a look in Ghidra, actually first let's look at the protections, because that's actually what makes this challenge a little bit tricky. So the protections, you can use checksec and then just pass it the file. So we can see canaries are enabled, non-executable stack is enabled, and pi is enabled. The important ones for this one, I guess, is stack canaries. Thankfully, the function that has the buffer overflow isn't using a canary. Otherwise, this would be even trickier. Yeah, and also pi is enabled. So there is a ret to win function, which we'll find, but we can't jump directly to it because we don't know the address of it. But otherwise, the challenge really wasn't too bad. So if we take a look in Ghidra, here's the main function. It's going to print out some stuff. It's going to call this input function. The input function is going to define a 50 byte buffer on the stack. And then it's going to read in OX 50 bytes. So OX 50 bytes is definitely more than 50. It is 80 bytes. So we have a 30 byte excess to work with for our buffer overflow. Then it's going to print out whatever we inputted. So useful gadget. So we have a buffer overflow and potentially an info leak here. The problem is, like I said, pi is enabled. So in this buffer overflow, we can overwrite the return address on the stack, but we don't know where to jump to. We'll come back to that. If we keep looking through the functions, eventually we'll find this function that's just called underscore. And this is our ret to win function. It's going to open up the flag file and print out the flag. So the trick to this challenge is remembering that when you actually, let's load it up in GDB, GDB chal, run, cancel via map. So even with pi enabled, there is a lot of randomness to the binary. Pi is not enabled because I'm running it in GDB, but pretend this address was more randomized. We can see the last 3 nibbles here. So the last 3 4-bit pieces, they all end in zeros. And so even though these different pages or these different sections are kind of like, randomized in memory, we know these last 3 things will always be the same. And what that means is, like, if we look at this main function, so when we call this input function, when we call input here on address 1359, it's going to push this address onto the stack. And so we don't know what the high portion of the address on the stack will be, but we know that it's going to end in a 35E. And also because of endianness, specifically little endianness, when we do this buffer overflow, what we can actually do is just overwrite a single byte of the return address. And so what that means is we know that the very last byte of the return address on the stack is going to be 5E. So what we can do instead is we can overwrite this instead with any value that is nearby. So as long as they start with a 1-3 and we just overwrite this last byte, we can jump anywhere here and we know we're going to jump there. So what we're going to do is we're just going to jump back to 5-9 so that input is called again. And so now we can do this buffer overflow as many times as we want. As long as we overwrite that single byte with the 5E or 5-9 or whatever. And what's useful about this is this puts call. We have our info leak here too. So when it calls puts, it's going to print out what we said. But as long as there's no null bytes, it's just going to keep printing until it encounters a null byte. And what that means is it's actually going to print out our buffer overflow, and then it's going to print out the address of where we're returning to, the return address, because after that there's a null byte. So we're going to overwrite that single byte, and then we're also going to get the address that we're jumping to from this puts call. And so just from there, we get to do our buffer overflow again, and we have our info leak. So the second time we go into this input function, we know we had our info leak, so we know where all these functions actually exist. And we can then put in the full address of the win function as our return address and just jump directly to this. To see what this looks like in code, I'm just going to cover this the first time. The rest of the time I'm not going to cover it. So we're going to import a bunch of stuff. We're using pwn tools. I disable warnings for bytes. I shouldn't, but I do. This is how we set up context. So I'm loading up the elf. I'm telling pwn tools what type of binary it is. You can do it like this. I'm setting the log level to debug so we can see what's going back and forth between the process or the server or the process. I use tmux for terminal splitting. So if you do that, it's useful to do it like this. We're connecting to the remote host. The first thing I needed to do was figure out where in the buffer overflow the return address starts. So one way to do that is just use pwn cyclic. I'll just show how to do this once. So we're going to do right here, p send after. I'm going to copy this out. And instead of sending this, we don't know where the offset is. We're going to send pwn.cyclic. Like I said, we're just trying to figure out how big of a buffer overflow we need. We know it'll read at least OX50, and we're going to do pwn.gdb.attach p. And then we'll do a p.interactive here. Cool. So let's run this. Python. Oh, first, let's go to tmux. Python 3 solve. Oh, right. We should can't run GDB on a remote process. Cool. So we sent this as that pwn cyclic we sent. And somewhere in here, we think it's going to cause a buffer overflow. So let's hit continue. And we can see we have a buffer overflow. Because it's so big, let me make it a little bit smaller so we can see everything. We can see, this might be a little bit hard to see, but we can see we get a seg fault. I'm going to make it a little bit bigger. Well, it's going to be a bit hidden, but anyways, we can see it's trying to return to this address SAAA. So we know that however many bytes that is where the buffer overflow starts. So that way you just don't have to count it yourself. You can just have pwn tools do it for you. So we know that SAA is the start of our buffer overflow. So we can get rid of all this stuff. So however many bytes that is, that's how many bytes we need until we start the buffer overflow or we start overwriting the return address. And then, like I said, we're only going to overwrite a single byte of the return address. So I picked OX1B. So if we look at what that is, that should be in the main function somewhere, and it is the start. So I am overwriting the return address with this byte. So normally it would return to here, so it would be a 5e, and I'm overwriting it with a 1b. The reason I'm doing a 1b instead of a 1a is this. I'm skipping this push call. That's just because on newer versions of libc, the stack needs to be aligned. I think when I jump to the win function, one of these things is using some libc function that requires things to be aligned, and it just didn't work out. If your code gets stuck somewhere in libc, look at the instruction and see if it requires stack alignment. If it does, you just might need to move the stack up or down by 8 bytes. Just something to keep in mind. So I bypassed that by just jumping to this one, so that way this push call wouldn't exist. But anyways, so we're going to jump back. Then we're going to get that leak. So like I said, it's going to leak out the return address. I do that here. First I receive until I get all of my A's back. Then after that, we know it's going to leak the return address. So it's going to be 16 bytes and then 2 null bytes, but they're not going to be printed. So we're going to read that from bytes, and then we're going to calculate the address of the elf, or where it's located in memory. And so we're just going to take our leak minus the elf.symbols for main, and yeah, should be good. And then after that, we're going to jump to the win function, p.sendAfter. This time we're going to send the same buffer overflow, but we're just going to jump directly to the win function, which is just this underscore, and start an interactive. I think I might actually be off by 1 byte because I'm doing 1a instead of 1b, but that's a different story. It still works. Cool. So let's check it out. Python 3, solve.py. And there we go. We get the flag. Integrity, hidden, ret to win, goes burr. So fun. The next challenge is pwn floor mat store. It says, welcome to the floor mat store. It's kind of like heaven for mats. I just realized, I think floor mat is supposed to be format, which is a format string exploit. No, I just got the joke. Anyways, the author is CryptoCat. We're given a netcat port and a download file. This challenge in my mind was easier than the previous challenge. For this one, we're just going to be exploiting a single format string, and really we're just going to be reading a string value off of a stack. So really not too bad of a challenge. This is what it looks like. This is the main function. It's going to define a bunch of different mats you can purchase. There's this mysterious flag mat for 1 through 37 values. From there, it's going to open up the flag file. Let's just call this flag file. Going to read that in. Then it's going to print out a bunch of these floor mats. It only prints out 5 of them. Some reason 5 and 6 aren't printed, but you can still select them. From there, you're going to give it a choice. So we'll select as our choice. If our choice is greater than 0 and less than 7, it's going to subtract 1 for some reason. Choice minus 1. If choice minus 1 is equal to 5, it's going to read in the flag into some local buffer. So we'll just call this flag buff. And then from there, we give it a shipping address. So this is our input buff. And then your floor mat will be shipped to, and it's going to do a printf input buff. So right here, we have a printf vulnerability on input we control. And so pretty much this, if you can make a printf repeatable, it's like always a guaranteed exploitation because you get your info leaks, you can do arbitrary writes. Printfs are just so powerful. But we don't even have to do anything complex here. If we choose 5 minus 1, so 6, if we choose option 6, it's going to read the flag into memory, and then we get a printf. So somewhere on the stack, the flag variable exists. So all we have to do is just do a couple of %s's, and the flag should just pop out. And that was the solution. So this is the solve script I ended up doing. So you need to send 6 minus 1, 5, so 6 as your input choice. So that way the flag is loaded into memory. And then we get our printf right after the addressing. So I'm sending $10$S. I just kind of guessed and checked. I sent a bunch of %Ps, and then I looked for values that looked like they would be on the stack. And I think there were like 2 or 3 of them. I tried those, and eventually %10S worked. If you're not familiar with the syntax, so %S means print out the stack value. Normally in a printf, backing up just a little bit, so you do like, hi, my name is %S, and then you put in the name variable, right? But with the printf exploit, if you don't pass a value, it's just going to read these arguments off the stack as if like you did pass arguments. So we can read whatever arguments we want. There's also a thing, I am %D, let's say. If you can also specify what positional argument you want, again, my name is, what you'll do is something like this. So you do %S. If you did %S, it's going to read the next argument. But if you wanted to read name again, you can do, I want the first argument, and you do it like this. So $1$S means read the very first argument. So using this syntax, these positional arguments, so we can specify any stack argument we want. Hopefully that made sense. But anyways, so we're going to select the 10th argument, which is just some random stack variable, and print that out. And that was the solution. Python 3, solve.py. And there's the flag, Intigriti. So that's why they warn about printf. So fun. The next challenge is Over the Edge. It says numbers are fun, and the author is Kavi Gihan. We're given a netcat port and a download file. The download file is actually a Python file. And with it saying over the edge, you can kind of guess that maybe it's going to be an integer overflow, and that's what the challenge ended up being. Again, this challenge really wasn't too bad. I think it was easier than the very first challenge, but it makes me think again I'm doing something wrong with the first challenge, but who knows. In this code, there's just like this handle client code. It's not too exciting, but basically it's going to take some input. We're going to pass the process an integer, and then it's going to call this process input function. And if it's U1, we get the flag. So we need this flag. We get to pass this function a number. And if we can get uWin to be true, we win. So to solve this, I just copied this out and placed it into a solve script over here, and I just started playing with it. So somehow we need to pass an integer here and get it to say U1. And it's also called over the edge, so you can kind of guess that it's an integer overflow. It's doing this numpy stuff, which maybe looks a little bit confusing at first. The reason it's doing this numpy is it just needs to have specific types so that we can do an integer overflow, specifically this uint64. Otherwise, Python integers will just keep going up and up in size and they won't overflow. But anyways, it's going to pass in this overflow. The code's a little bit weird, but basically, if you sit down and just kind of think about it, it needs this condition to be true, and this condition is true if your number is 2, so it's the max integer size minus, since we're subtracting here, we're going to do a minus 1 through 36, and they're also adding 65 here. I'm not sure why, but if we subtract 65, if we pass whatever this number is into the function, we'll find that the overflow works and it returns you win. And so we can test that real quick, ignore all that. Let me make this a little bit bigger. Python 3, solve.py, and we can see we get back U1. It even warns us that an overflow was encountered, which is pretty fun. I think that's numpy that does that for us, but I could be wrong. So we know what number wins, so all we have to do is just send it to the remote process. So you can just netcat to it, or you can do a solve script, but either way, this is what the solve script could look like. We're going to connect to the remote service. We're going to receive until it asks us for the edge. We're going to send that number that we just calculated, and we're going to wait for an interactive. So let's do that. And if we do that, we win. So Intigriti, fun with integer overflow. So cool. The next challenge is pwn Maltigriti. It says, I just submitted my third bug report to Maltigriti, a competitor of Intigriti, and it was closed as a duplicate. Can you figure out what is going on and get me my well-deserved swag pack? The author is me, Conrad, Salvage Pirates. We're given a netcat port and a download file. For this challenge, we're going to be exploiting a use after free. There's a user structure, and the user structure has a bio, and we can overlap that with the use after free with a report object. And when we have those two objects on top of each other, we can bypass some win checks and get the flag. The download file includes the C file, maltigriti.c, along with the binary, a make file, and a Docker file. So you should have everything to see how the challenge works. But we'll see there's this menu function. So we can register users, edit users, submit bug reports, print to bounce, buy a swag pack, log out, and exit. And so the idea behind the challenge is, this is just like a bug bounty. You submit bugs, and if you submit enough bugs and get enough value, in this case, you get swag packs. So there's this function called buy swag pack, which you can call from the menu. And so if your balance is greater than 1337, it will give you the flag. So this is the win function, and we need to get a balance. And if you don't, it keeps telling you to hustle hard or whatever. If we go to calculate balance, we can see it's going to go over this report structure. And so the report structure is just this linked list. Every time you submit a new report, it's just going to add to this linked list. And if it is accepted and it belongs to you, it'll increment this balance based off of the report bounty. Cool. So how do we submit reports? Well, there's this new report structure. Basically, you can give it a report title. You can give the contents of a report. We'll see there's this comment here. It says automatically mark the status as duplicate so we don't have to pay anyone, evil grin. So Maltigriti, they don't want to pay anyone, and so they're automatically marking every report as duplicate. And so they're very evil, and that they have some more text based off of how evil they are. Cool. So somehow we need to bypass that. The rest of the code involves user management, so we can kind of guess that the bug is going to be in there. And there's a couple interesting things. The bug actually exists within these two functions, this edit user and this logout function. So when you log out, this code's a little bit weird, like you wouldn't telnet into the weird process, and there's only this global user object, blah, blah, blah. So if user is not equal to null when you log out, it's going to memset your name, your password, your bio, and then it's going to free the user bio. But you notice it doesn't set any of these to null. They all still exist. And when you edit a user, if user is not equal to null and bio is not equal to null, neither of these are null after we log out. We can, it'll tell us what our old bio is, and we can update our bio. And so this is the use after free. So we can register a user, then free the bio, and then edit the bio. And so we will free a bio, and then when we submit a new bug report right here, malloc the size of report, we can overlap that with the bio and this new report object, as long as it grabs the correct chunk. And from there, we can start, whenever we edit the bio, we're going to edit this report. And so we can get this report a value of 1337 for a bounty, and we can set it to status accepted. And once we do that, we can get the flag. So to see what the solution looks like, this was the official solve script. We're going to connect to the remote server. We're just going to go through the menu. First, we're going to register a user. We're going to set the name and the password to Sloppy Joe Pirates. We get to specify the size of our bio. I'm doing 192. If you run through the code in GDB, you can see the malloc. You can break on a malloc and see how big a report structure is. That's how you can get the size. So we're saying a size of 192, and then a bio of just hi. It can be anything. After that, we're going to log out. And so now we have our dangling free chunk. Then we're going to create a report. So the report is going to have a size of 192 based off the report structure. So we're going to create a report. We're going to send it a title and a body. So we're all set. At this point, now we're going to edit the bio. So we're logged out, but the user structure still exists. So we're going to edit the user. Thankfully, it actually, when you do that, it says your previous bio was blah. In there, we're actually going to get a leak to the user structure, which we need for the report object because it has a pointer to the user ID when it calculates bounces. So we can leak that out. And then after we have that, we're going to create the fake report in our bio since those chunks overlap. So we're going to put in the user ID, just showing what the report structure looks like. We can see in this report structure, it has a pointer to the user. So we're going to overwrite that. We're going to overwrite the status, and we're going to give it a bounty that we want. And so that's what we do. We overwrite the user ID. We overwrite the accepted, A for accepted, and we give it a value of 2000. And then after that, we can request our swag pack, which is option 5, and we should get the flag. So Python 3, solve. And after all that, we get the swag pack. Integrity, use after free sounds good to me. So I would say it's a fun challenge, but I built it so I'm biased. So the last Pwn challenge is reading in the dark. It says you can't read without the lights, can you? The author is IQIMPZ. We're given a netcat port and a download file. For this challenge, we're going to leak a bunch of stuff using printf, and then we're going to do a buffer overflow and jump to a one gadget. I think this, I don't know if this was the intended solution, because there's a lot of code, but it worked and it wasn't too bad. For this challenge, I think it's very useful to use a tool like Pwn to make sure that you're using the correct version of libc. So if you haven't used Pwn it's just some project. You can find it on GitHub. If you run it, it'll take a libc in your directory and unstrip it and find the correct linker loader. And that way your binary should, as closely as possible, match the remote system. So I did that. That's why you see the binary is called RITD patched. It just means I used a tool called Pwn. So highly recommend doing that. Otherwise, then let's take a look in Ghidra. So a lot of this challenge was actually, not a lot, but part of it was reversing. So you're kind of given this weird protocol, and you just kind of have to figure out how the protocol works. Thankfully, it's a text-based protocol, not like a binary protocol. And so while you're in this like repeating menu function, you just kind of have to figure out what the validate data function is doing and this parse function is doing. But we can see each time we get some input, which is this one. I'll just rename it. We get to read in 256 bytes into input. It's going to validate it. If the validate is not correct, it's going to exit. And then it's going to parse out some function, and our function is our choice. We figure out that the data format, I'm just going to write it out here. It goes timestamp, function ID, I'll just call it ID, and then data. And that's just how the format works. And ID is just a number. So it's going to validate data. It's going to parse the function. So if the function ID is 4, it'll do this admin read function. If it is function 3, it'll do a read in the dark function. If it is a 1, it'll print out the current time. And if it is a 2, it'll echo our input. So we have a couple of useful functions. It turns out we only really need 2 of them, I think. The first one is the parse function, which is called every time. If we go into this, so this is what's going to take the middle content or middle data and just print out the function number. But there's a bug here. So again, the code's a little bit messy, but like I said, basically it's going to take that structure. We can see it right here. So this is going to read in, this is function ID 1. It's just going to print out function 1. But there's a bug. It actually does a printf on the entire string that's in between. So what we're going to do, as it parses it out, you can go through the code if you want, but if it's like this, this would just print function 1, but you can actually put in a bunch of stuff, specifically printf sort of exploits, and so it'll print 1, and then, whatever %s is on the stack. And since it's a printf exploit, we can use this to leak values. You might have been able to use this printf to do like a full exploit. You have to be careful with null bytes though. It didn't seem trivial and I didn't want to muck with it, so there was a easier buffer overflow later, but this might be the only gadget you need if you're clever. But anyways, we can use this printf to just start leaking values. So we're going to pass a value. You can actually see it right here in the solve script. We're going to pass in a $3 sign P, a $75 P, $77 sign P, and a $1 sign P, and we're going to get leaks for everything. This binary has all the protections enabled, so we need leaks for libc and the stack. We don't need a stack leak, but libc, the main elf, and yeah. And a canary, because we're going to be doing a buffer overflow later. Anyways, so we have all of our leaks from this. Then I said there's that other interesting function, this admin read. So if you pass in, I think it's like function ID 4 or something like that, it'll call this function. This function's a little bit weird. So there's this like timestamp validation code that happens. And so as part of that, your timestamp has to match the remote timestamp within like 20 seconds or something like that. And that just has to happen every time you send a command. So in the solve script, there's a function called getTime. I request this time from the server. And so that way I always know what the remote server is every time I send an instruction. So like right here, I'm going to send an instruction and I just place in whatever time the remote server thinks it is. So anyways, so there's that happens every time in the menu function. But this admin read has this parse timestamp new, which is interesting. There's a parse timestamp and a parse timestamp new. The difference is parse timestamp new returns a long and parse timestamp returns an int. A little bit strange, but what's weird is this admin code will only be called if the timestamp is like a very large number, like 189, which is larger than the timestamp returned by the server. So we need to bypass this, and to bypass this, we're going to be doing a integer overflow, kind of. So there's a way that we can have it such that when it calls ASCII to integer on our value, it'll return one value for an integer and a different value for a long. And it's not really validating the long value, just the long value needs to be large. So we're going to trick this ASCII. There's a ASCII integer, and like I said, ASCII to long. Let's go to ASCII to integer. This ASCII integer, if we pass in, I think it's undefined behavior technically, but if you pass in a value that's longer, it'll just get wrapped back down to an integer size, 4 byte size. Anyways, so that's how we bypass that check. We're just going to pass in whatever the correct timestamp is, and then we're just going to add on, 2 to the 64, 2 to the 32. I forget which one. 2 to the 32. Cool. So we can bypass that first check for the admin read, and then after that, it's going to do a scanf. So it gives us a gadget where we can write an arbitrary byte anywhere. This seems very powerful, but I don't think it's too useful, just because there's full railroad, so we can't overwrite the global offset table, and there's just no obvious targets outside of that either. But thankfully, at the very end, it asked, did you read what you wanted to read? And it's going to read an OX 40 bytes into local 38. If we look at 38, it's only 40 bytes. A very common trend in the CTF where we define a 40 and an OX 40 here. So we have a very clear buffer overflow. It is going to do a canary check. So if we're going to do this buffer overflow, we need to know what the canary is. Thankfully, we can leak that from the printf. And then we can return to an arbitrary address. Since we have libc, we're just going to jump to a one gadget. If you're not familiar with one gadgets is a way where you can get shell from a single arbitrary jump. And the way it works is there's just certain places you can jump to in libc that everything just kind of aligns up correctly such that it calls shell. And thankfully, most of it happens within the system syscall, the system libc function. But for example, if we were to jump to this address with the base offset of libc, this function will be called. So these conditions have to be true for the function to succeed. But as long as we can get one of these to work, we get shell from just a single jump. So we're going to overwrite the return address with one of these. And yeah, that's pretty much it. So we're just going to be doing a printf. We're going to leak a bunch of values, some addresses, a canary, and then we're going to do this as buffer overflow. We're going to do the integer overflow to kind of bypass these timestamp checks, which really isn't too bad. And then from there, we do the buffer overflow. We write a one gadget, and we should get shell. To see what this looks like in the solve script, this is all just standard stuff. Loading in libc here, we can see. This is the function just to get time. I just pass x1x, and then it returns the current time. When I get the current time, I add on this number. And so this is just 2 to the 32, or 4 bytes, or max value for 4 bytes. So that way it passes both the long check and the int check on the admin thing. So step 1 is we're going to use the that function ID printf vulnerability to get a bunch of leaks. I forget the order. I guess this is if I just did a whole bunch of %ps and saw what the addresses look like, and I saw that this 3p looked like a libc address, so we got that, and then I calculate the offsets. If you just run it in, if you just do a VM map within GDB, you can see what the base address is, and then you have your leak address, and you know this is always going to be a constant value, and then you can subtract that from whatever leak you get in the future. So we get the libc leak, we leak out a canary, we leak out the main elf address, and then I also leak a stack value. Originally I was going to do something with a stack. You technically don't really need this. But anyways, then we print out all of our leaks. And then from step 2 is just use that buffer overflow. We're going to overwrite the return address with the one gadget. So I just took all the addresses out from that one gadget code. And from there, we're going to construct a message for. This is going to put us into the admin code. It says we have to write an arbitrary byte somewhere. So I just give it some arbitrary stack address that we just got from earlier. We just need to make sure it's in a writable segment of memory. We're just going to write some value. I just write an F there. And then from there, this is our one gadget address. It's the base libc plus our one gadget. And then I found an arbitrary return address. I don't think I used it. No, I didn't end up using this. For a while, I was having some alignment issues, I think. And yeah, then we're going to do the buffer overflow. Did you read what you needed to read? We're going to fill up the buffer overflow. We're going to place our canary there because there are canary checks. We're going to place a somewhat valid stack pointer address on the stack just because it's needed. And then we're going to place our one gadget. And from there, we should get shell. So we can run it, Python 3, solve.py. It's connecting, doing all the code, and ls, and we have flag, so we can cat it out. Flag.text, integrity, what is the point of reading in the dark? So fun. And that is all the Pwn challenges. So thanks to Intigriti for hosting, and I will see all of you at the next CTF. Cheers.